In this video, I'm going to do problem number 4 from quiz number 3. It says the formula for the volume of a cone with radius r and height h is v equals 1/3 pi r squared h. Since a cone may be thought of as a solid of revolution, derive this formula using the method of disks. Okay, now I gave a hint here. Consider the line segment that connects the origin to h comma r. What is the equation of this line? Revolve the region under this line about the interval 0 to h, above the interval 0 to h, about the x-axis. Okay, so I've drawn a picture here of this region. So this is the point h comma r right here. And of course, here's the origin. If we take this region here and revolve it around the x-axis, you see it becomes a cone. I've drawn the cone over here, and the cone has a height of h and a radius of r. So if we can find the volume of this solid of revolution, then we'll have derived the formula for a volume of a cone of radius r and height h. Okay, now what we're going to use is the method of disks, because if we make a little x value here, and draw a little rectangle above it, when this spins around the x-axis, it will become a disk. Okay, now one of the things we need to have is the formula, though, for this line. Now this is a straight line, so it should have the equation y equals mx plus b. But the b is 0 because the y-intercept is 0. And so the one thing remaining to do is to find what is the slope of this line. Well, we know the slope of the line, m, is going to be r over h. Okay, rise over run would be r over h. So that y equals mx would really be y equals r over h x. So that's the formula for this line. So now we're going to use our formula for the volume of disks, which says the volume is the integral from a to b of pi times f of x squared dx. And using the numbers for this problem, we would integrate from 0 to h, because this number over here is h. If this whole length is h, then that number right there is h. Integral from 0 to h of pi times our f of x, which is r over h times x, our f of x squared, so we square that, dx. Okay, now we can do some simplification. We can take the pi out front if we want. And also we can square r over h times x, and we would get r squared over h squared times x squared. Now we're doing an integral with respect to x, so we think of x as the variable and r and h are constants. So we can pull the r squared over h squared out in front of the integral, and we're still integrating from 0 to h of x squared. Okay, guess I don't need that dot there, but so the integral of x squared, though, is x cubed over 3, and we're integrating from 0 to h. Now when you plug in 0, you just get 0, but when you plug in h, you get h cubed over 3. Now that h cubed, two of those h's will cancel with this h squared on the bottom, and what we're left with is pi times r squared times h over 3, because two of these h's canceled with these two h's down here. And notice that's exactly the formula that we were looking for, 1/3 pi r squared h. Okay, so that was the formula for the volume of a cone of radius r and height h.